We're going to cover the second part, which is completing the square. And so we're going to solve quadratic equations by completing the square. And then we're going to solve quadratic equations by the quadratic formula. Now, completing the square, I would have to say, is the least favorite way of mine to solve a quadratic equation, and usually for most students it is too, because it's something that you don't have to do, but it's something that you can do to solve a quadratic equation. But the reason why we teach this section is because of the actual method that we go through to complete the square, because we have to use this method. We have to use completing the square to do other things. Like we go over circles, we'll have to use completing the square to change the equation of a circle. So there's several different math topics where you have to use completing the square. So we're going to introduce that way of solving an equation using completing the square, just so you'll know the method. So I'm going to start off with not an entire problem, just part of a problem. So let's say that I had x squared minus 16x, and then usually I'd have, plus some number, maybe equals 0. But like I said, this isn't the entire problem, this is just part of a problem. And so to complete the square, what you do, the method that you go through, is you take half of what's in front of the x, and then you square that. So half of what's in front of x, half of 16 is 8, right? So 8. It's really negative 8 if you think about it. Half of negative 16 is negative 8. But if we take half of that and square it, the negative is not really going to matter, right? So then I would have x squared minus 16x plus 64. And so what this is, this quadratic equation now that I have with all three parts, the trinomial, this is something that will factor into a perfect square. So what is a perfect square? Remember numbers like 4 is a perfect square because it's 2 times 2. 9 is a perfect square because it's 3 times 3. So whenever this factors, this will factor to be a perfect square. Something times itself. So let's use our factoring skills that we brushed up on last class meeting. And how would that factor? We would say x, and then one way to get 64 is 8 times 8, right? And so either a positive 8 and a positive 8, or a negative 8 and a negative 8. If I take the product, I get positive 64. Well, how would I need to add those together to get a negative 16? They'd both have to be what? Negative 8, right? So you can see that by me doing this method, I have changed this quadratic into something that would be a perfect square, or something times itself. Another way to write x minus 8 times x minus 8 is x minus 8 squared. Okay? So, like I said, that was just part of a problem. So let me show you what it would look like if we wanted to work out and solve a quadratic equation by completing the square. So we'd start out with x squared minus 6x plus 1 equals 0. Now, you need to have a couple of things going on in the problem to be able to complete the square. One thing that has to be there is you have to have a 1x squared. If you don't have a 1x squared, then there's going to be something you're going to have to do in the problem before you even try to complete the square. So as long as you have a 1x squared, you can solve the quadratic equation by completing the square. Now the way that I like to do this, and we're going to make this into a perfect square. The way I like to do this is I'm going to move the number term or the constant term over to the right side, and where it was I'm going to put a plus blank, like something for me to fill in. So if I move this plus 1 from the left side to the right side, then that's going to be x squared minus 6x plus blank equals, and if I move the 1 over, that's going to be negative 1, right? And so I'm also going to put a plus blank on the right side of the equation. Now, for it to be an equation, the thing about an equation is anything you do to one side of an equation, you always have to do the other side of the equation so that you can keep equality. All right? So we're going to figure out what goes in that blank on the left side such that it will factor to be a perfect square. And we're going to follow that same pattern that I showed you on the previous problem that wasn't a whole problem. So what did we do to get what we put out here, this constant? We always take half of what's in front of x and square it. So half of what's in front of x, half of 6. We can think of it as half of negative 6, but I don't want to confuse you because that's not really going to matter. So not at least for me putting my number in the blank. So half of 6 is 3. So I want to put 3 squared right here. And you can either write it as 3 squared, or you could write it as 9 because that's what 3 squared is. But what you do on one side, you have to do on the other. Okay? Now the left side is guaranteed to be a perfect square. So how will it factor? Well, there's actually a pattern you can go through to factor it every time, and it'll work out using this pattern I'm about to show you. So, of course, we put x and x first. Then look at the sign in front of the middle term. If it's negative, we're going to put minus and minus. If it's positive, we'll put plus and plus. Okay? And then whatever the number was that we were squaring, so if you write a 9 here, you have to remember, well, how did I get 9? Well, it was 3 squared. So the number that we were squaring, that's what we put here and here. All right. Again, let me just go back through what I did. So to start the problem, I made sure it was a 1x squared. Then I moved the positive 1 over, and it became a negative 1. Where I had a positive 1, I put a blank, and I also put a plus blank on the right side of the equation. Then to get what goes in the blank, I take half of what's in front of x and square it. So that gives me 3 squared, or 9, that will go in each blank. Now the left side is guaranteed to be a perfect square, something times itself. So you write down your x's first, then look at the sign in front of the middle term, write minus, minus, and then whatever you got, whenever you took half of what was in front of x, you put that as the number in each one of your factors. Now that equals, now I have negative 1 plus 3 squared is 9, right? Now the left side of the equation becomes x minus 3 squared. Something times itself. All right, that perfect square. The right side of my equation becomes what? I have negative 1 plus 9, so that's going to be a positive 8. All right, now this kind of looks like the problems that we were working last class meeting, where we were using the square root property to solve, doesn't it? It should look just like one that we worked out. So if I want to solve for x, I take the square root of both sides of the equation. Now remember, the square root and squared, those cancel out. So I have x minus 3 equals, and then anytime you take the square root of both sides of an equation, you have to put a plus or minus with one of the sides. We're going to put the plus or minus in front of the square root of 8. And we need to simplify the square root of 8. So I'm going to write down one more step here. I'm just going to copy everything down. So that's going to be plus or minus. Now the square root of 8, what is that? That's the square root of 4 times the square root of 2, right? Or 2 square roots of 2. Now to solve for x, I need to get x by itself, so let's add 3 to both sides. And remember, when you bring this number over, you have to write it in front of the plus or minus. Okay, so that cancels out. I get x equals 3 plus or minus 2 square roots of 2. Now remember, that's 2 answers. Anytime you have plus or minus, you have 2 answers. So my 2 answers, or my solution set, is 3 plus 2 square roots of 2 and 3 minus 2 square roots of 2. You're going to have to enter in, that's how you want to enter in your answers for your online homework. Alright. Here's another problem. Let's look at this one. Let's say I had x squared plus 6x equals negative 2. Alright, so I need to check and see if I have a 1x squared, and I do have a 1x squared. So I don't have to do anything special to this. Now I need to see my number part, or my constant. I don't have one on the left side. It's already been moved to the right side, so that's okay. You can leave it like that. Just where you would have a constant, put a plus blank and a plus blank. So we want to put a plus blank on both sides. So that reminds me that I'm going to have to figure out some number there that would make that a perfect square, where it'll factor into something times itself. To get that, you take half of what's in front of x and square it. So half of 6 is 3. 3 squared is 9. This time I'm just going to write a 9 here. It's kind of like one less step that you would have to do if you remember to square the number. Alright, so the left side is going to factor. It's going to be a perfect square. It's guaranteed to be a perfect square because that's what we just made it into. So I write down x and x. Look at the sign in front of the middle term. It's a plus. So this time I put plus and plus. And then what was the number we had to square to get 9? 3, right? So you put 3 and 3. And then negative 2 plus 9, that's positive 7. So the left side of the equation becomes x plus 3 squared, and that equals 7. Now take the square root of both sides of the equation because we're trying to solve for x. So when you take the square root of both sides of the equation, the left side is going to become x plus 3. Remember, you just get rid of the radical. The right side is where, when we take the square root of both sides, we have to put a plus or minus, so it's equals plus or minus the square root of 7. And the square root of 7 will not reduce. Alright, so we have to leave it like the square root of 7. Now to solve for x, I subtract 3 from both sides. Alright, and so I get x equals, remember you got to put that minus 3 in front of the plus or minus. So that's going to be negative 3 plus or minus the square root of 7. And remember, that's 2 answers. So my solution set is negative 3 plus the square root of 7, and negative 3 minus the square root of 7. So we have to remember the pattern. The main thing, I guess, once you set this up and you have it written down as a perfect square, well, then the problem is just like the ones we were working last class meeting. The main thing we need to remember is you take half of what's in front of x and square it. So this could be a number that would give you a fraction, but don't freak out if you see a fraction. Alright, I know we're just doing all whole numbers, but that could happen. Okay, so half of what's in front of x and square it, and then whatever you put on the left side, you have to also put on the right side. You want to add anything to that? All right, any questions? Again, this isn't the best way to solve a quadratic equation. This is just another way to solve a quadratic equation. Now, the next way that we're going to learn how to solve a quadratic equation will work with any quadratic equation. It doesn't matter if the quadratic equation will factor or not. It doesn't matter. You could use the square root property if it's set up where you could use it. You could still use this method. The quadratic equation will work with any type of quadratic. So hopefully you can remember the quadratic equation or the quadratic formula for a quadratic equation. Maybe in high school you had to sing the quadratic equation song, or write it down and write it down and write it down until you could finally remember it. Anybody want to sing for us? No? Trey, you want to sing for us? Alright, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So negative b plus or minus the square root of b squared minus 4ac all over 2a, right? I don't know, maybe y'all can sing better than me, but it was just an easy way, I guess. You know, if you learned this in Algebra 1 or Algebra 2 in high school, then it was an easy way for the teacher to get you to make it a little more fun, because we all know how much fun this is, right? Alright, so where do all these A's, B's, and C's come from? Because I haven't written down A, B, or C in anything yet. Well, they come from the general form of a quadratic equation. So you remember, the general form of a quadratic equation is ax squared plus bx plus c equals 0. So that's where your A, B, and C come from. And it is very important that you recognize if they are positive or if they are negative, because it does change your answer. Alright, if they're positive, then when we plug them in, we want to make sure we plug in a positive number. If they're negative, plug them in, we'll make sure we plug in the negative number. It makes a big difference. Alright, now before you can work out or solve a quadratic equation using the quadratic formula, we do have to have it set equal to 0, just like we did when we were factoring. So that's very important. Alright, so let's solve this quadratic equation using the quadratic formula. Let's say that we had x squared plus 2x equals 7. The first thing we need to do is put this in standard form. I may have called it general form, but we just want to put it in equal 0 form. So I need to move the 7, the positive 7 on the right, I need to move it over to the left, and that'll change the sign of that. So I have x squared plus 2x minus 7 equals 0. Alright, the next thing I like to do is write down what a, b, and c are equal to. That way, whenever I look back, I won't just have to keep looking back at the equation and figuring it out over time. I'll have it written down. So I have a equals a positive 1 because this is 1x squared. B equals a positive 2, right? And C equals a negative 7. So now that I have what a, b, and c are equal to, let's look up here at my quadratic formula. And we're going to plug everything in parentheses. I like to plug it in parentheses if it's positive or if it's negative. Alright, so I have x equals negative b. So I have negative of 2. Alright, that's what b was, a positive 2. So I'm going to have the negative of 2 plus or minus the square root of, I'm going to plug in my b again, so it's 2 squared minus 4 times a is 1, times c is negative 7, and then make sure you put all of that over, not just part of it, but the whole thing over 2a. So 2 times a was 1. Now, some common mistakes that students make whenever they plug things in, sometimes they'll forget this minus right here. We're always going to have minus 4. Always. And that's a negative 4. So when you multiply all these numbers in a row that don't have signs between them, or that are in parentheses, when you multiply all of those, you have to remember to treat that like a negative 4. So that's a common mistake that students will make. Also, remember when you plug in something for b, if you plug in a positive, it has a minus in front. That's going to make it negative. Alright, so now I'm going to start simplifying. Alright, so I have the negative of 2, that's negative 2, plus or minus the square root of, now 2 squared, that's 4. And now here's where I need to multiply some numbers together. I want to say negative 4 times positive 1 times negative 7. So negative 4 times 1 is negative 4. Negative 4 times negative 7 is positive 28. So I'll put plus 28. And that's all over 2 times 1, or 2. Alright, so I have negative 2 plus or minus the square root 4 plus 28, that's 32, all over 2. Alright, so I need to see, can I simplify my radical there? So is there a way to simplify the square root of 32? Are there two numbers we can multiply together and give us 32, where one of them is a perfect square? Yes, right? What could I do? Eight and 4 does give me 32, and I guess 4 is a perfect square, but is there a larger perfect square? What about 16? Is there 16 times something? 16 times 2 is 32. So this would be the square root of 16 times the square root of 2. That's another way of writing that. Okay. So that's equal to negative 2 plus or minus 4 square roots of 2 all over 2. Alright, now, once we get to the very end, if we have all real numbers, we still want to see if things will simplify. So do you think that I can do this right here? It would be nice if we could, but remember, as always, it's a little tricky if you have multiple terms on top and then one term on the bottom. You can't cancel out like that. So you have to, for problems where you use the quadratic formula, to simplify, you have to cancel out between the number in the denominator, the first number, and the number in front of the radical. So you have to be able to divide all three of those by the same number. And what can we divide all three of those by? 2, right? You can divide the denominator by 2, you can divide this first number by 2, and you can divide 4 by 2. So the denominator is going to become 1. This first number is going to become a negative 1. And then this is going to be plus or minus. When you cancel out here, that's going to be 2 square roots of 2. So let's rewrite that and see what we have. So I have negative 1 plus or minus 2 square roots of 2. And that's all over 1. So we don't have to write a denominator of 1. Alright, so we have solved for x. And that gives us 2 answers, right? Because we have a plus or minus there. So I have x equals, here's my solution set, negative 1 plus 2 square roots of 2, and negative 1 minus 2 square roots of 2. All right. Right here. So when I rewrote this, I had to rewrite the square root of 32 as the square root of 16 times the square root of 2. And then the square root of 16 was 4. So once you have it in this form, then you need to check and see if it'll simplify. So we had to divide the denominator by 2, the first number by 2, and the number in front of the radical by 2. Now, if for some reason you can divide between 2 but not the other, then you can't simplify. But you have to be able to divide something into all three of those numbers. All right, let me do another one of those. So let's say that I had 3x squared plus 11 equals 5x. Alright, so this is not in standard form or general form, whatever you want to call it, for a quadratic equation. So I need to move the 5x from the right side to the left side so that it'll be set equal to 0. Alright, now remember we write the x squared term and then we write the x term. So, and then we write the constant, or the number part, equals 0. So I have 3x squared. When I move the 5x over, what is that going to do? It's going to make me have what? Minus, or negative 5x, and then plus 11 equals 0. So that's the form that I want to have this in to use the quadratic formula. Alright, some of you may be thinking, well, why don't we just use factoring every time? Well, everything's not always going to factor. So you can sit there and try to factor this all day long and you're not going to be able to figure out what it's supposed to be. I wouldn't be able to figure out what it's supposed to be. Alright, so it won't factor the way that we factor things. So what we have to do is use some other method. Well, quadratic formula. So let me write the quadratic formula down again. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Alright, now I want to write down what A, B, and C are equal to. So I have A equals 3, B equals negative 5, right, because it's a minus 5x, and then C equals 11. Remember, we're only taking, these are called coefficients, so we're only taking the coefficients of each term. A has a coefficient of 3, the middle term has a coefficient of negative 5, and then the constant term is 11. So now, let's plug those into our formula. X equals negative, and then remember, I'm plugging in everything in parentheses. So my B is a negative 5. So the negative of negative 5 plus or minus the square root of, I want to plug in B again, but I'm squaring it this time. Make sure you put it in parentheses. That's negative 5 squared. And then minus 4 times A times C. So that's 3 times 11. So we've got to be careful there. So I had negative 4 times 3 times 11 all over 2A. So 2 times 3. Alright, so let's be careful when we simplify. Let's see what we would get. So I have X equals, the negative of negative 5 is positive 5 plus or minus the square root. Alright, so then I have negative 5 squared. That's negative 5 times negative 5. So it's positive 25. Alright, so here I have negative 4 times positive 3. That's negative 12. Alright, and then I have negative 12 times 11. Remember that times table? Negative 12 times 11. What would that be? Negative 132, right? 12 times 11 is 132, right?
Remember, you can take the first digit, last digit, the middle one's the one and the two added together.
Ah. So, again, make sure you multiply from left to right, and make sure that you write down the right positive or negative sign as you go. So I had negative 4 times 3 is negative 12. Negative 12 times 11 is negative 132. That's all over 2 times 3. That's 6. So let's simplify under our radical. We have 5 plus or minus the square root. 25 minus 132. So if you say 25 minus 132, you get a negative, what? 107. If you don't believe me, punch it in your calculator. 25 minus 132, you should get a negative 107. It's okay to get a negative under the radical because we know how to rewrite that, right? We've learned how to deal with those negatives under radicals. So how do I need to write that? 5 plus or minus. So how can I remove the negative under a radical? I have to do what? Put an I in front. That's right. So I'm going to say that's going to be plus or minus I times the square root of 107. All over 6. Alright, so if I'm able to simplify this any further, I have to first see, can I simplify 107? Well, no. I can't divide a perfect square into 107 to help me simplify that. So it's just going to stay the square root of 107. Then I need to look at the term in the denominator, look at the first term right here, and look at the term in front of the radical. So unless you can simplify between 5, 6, and 1i, then, and you can't, there's no number you can divide into 5, 6, and 1, or 1i, to simplify. So we're almost done with this problem. We almost have our answer. The reason why I say we almost have our answer is because remember, with complex numbers we have to write the real part and the imaginary part, right? So this is equal to, we say this first number, 5 over 6, and then we have plus or minus, and then I have I square roots of 107 over 6.
Yeah, will my math take it like that now? It used to not.
Yeah, now there is a chance that your homework won't take this form, because instead of writing the I in the front of the radical, they like you to write it at the end of the fraction part. So this is 5 over 6 plus or minus, and you would even be able to leave it in the numerator if you wanted to, square root of 107 over 6, and either write the I, you have to write it on the outside of the radical. You can't write it under the radical, or you can come to the side of the fraction and write the I.
It used to take it only as a single fraction.
Okay.
I don't know if it still does or not, like that.
So if you did write that as a single fraction, you would have to put the square root of 107 and then the I on the outside of that over 6. That's the way that I'll write my final 2 answers, because remember, this is 2 answers because you get plus or minus. So my solution set is 5 over 6 plus the square root of 107 I over 6 and 5 over 6 minus the square root of 107 I all over 6. So that's the way that the online homework used to want you to put it in.
If you scroll back up a little bit, I don't know, it may be different, but you used to have to put it in like that.
Okay, like this?
Like that,
I've never had any problem putting it in.
It used to not.
So,
I don't know.
yeah, you may just have to, if you're unsure, if you think your answer is correct, then what I would do is maybe view an example and see how their final answer is put in, and then that would be the way you would want to make sure your final answer is put in. All right, any questions on the quadratic formula? So the main thing you need to remember with the quadratic formula is move over all the terms to one side and have it set equal to 0. Figure out what A, B, and C are equal to, and then when you plug them in, make sure you plug them all in parentheses. That way you will change minus a negative into a positive, or if you're multiplying, you'll remember to multiply by putting it in parentheses. So the quadratic formula always works. So you may be thinking, what do you mean it always works? Well, even if you have something like this, x squared minus 4 equals 0. Well, we could solve that using the square root property, right? And we would get x equals plus or minus 2. Well, it'll still work with the quadratic formula. If for some reason you wanted to use the quadratic formula, you would just let a equal 1. Now you don't have an x term, or just an x to the first power, so you let b equal 0 because you're missing that term. And then you would let c equal negative 4. And if you went through with the quadratic formula and you plug those numbers in, I guarantee you, if you work it out correctly, you'll get plus or minus 2. So if you're unsure, you could always use the quadratic formula. Now I'm going to show you something just a little bit extra today, and this might be a little confusing, especially if formulas that have lots of variables in it kind of confuse you a little bit. This may seem confusing, but I want to give you all a little bit extra today, just so you can maybe go show somebody this one day. Even if they're in calculus, I bet you that they won't know what I'm about to show you here. Okay? I'm going to show you where the quadratic formula comes from, And all we're going to use is all the same tools that we've been using. All right? Remember, the general form of a quadratic equation, or standard form, is ax squared plus bx plus c equals 0. So again, let me reiterate. What I'm about to do, if it confuses you, don't worry. You won't be tested on it. That doesn't mean turn your brain off. That just means I'm going to show you where the quadratic formula actually came from. All right? So that's the general form of the equation, of a quadratic equation. Now, if I wanted to solve this by completing the square, well, I told you had to have a 1x squared, right? So you can divide, to get a 1x squared here, you would have to divide everything, or you'd have to divide this term by a, right? So that they would cancel out. But you can't just do that without there being some kind of consequence. If you divide the first term by a, then you have to divide the second term by a, the third term by a, and mine as well, the other side of the equation by a as well. So I divided everything on the left side by a and what's on the right side by a. Now 0 divided by a is still 0, so that's not going to change anything. So what would I have after I divide everything by a? Well, I would have, that would cancel out, and I'd have x squared plus b over a times x plus c over a equals 0. Alright, so all I've done is divided everything by a. Now, what was the next step if I complete the square? Move the constant over. So you see where I have this c over a, that's going to be a constant term, so I'm going to move it over. So I'd have x squared plus b over a times x. Then I'd have my plus blank equals, and when I move that over, that becomes negative c over a plus blank. Alright, so remember, what was our next rule? Our next rule when we were completing the square is take half of what's in front of x and square it. Well, when you take half of something, that's the same as multiplying it by 1/2, right? If I want to take half of 16, multiply it by 1/2. That'll give me 8. If I want to take half of 100, multiply that times 1/2. That'll give me 50. Right? 100 over 2. So, if I want to take half of b over a, I'm going to do that to the side. So, if I want to take half of that, I just multiply it by 1/2. So that would be b over 2a. Now remember, what do we put in the blank? We take half of what's in front of the x and square it. So half of what's in front of the x is b over 2a, and square it. So I'm just going to write b over 2a squared. b over 2a squared. Alright, well, what is b over 2a squared? Let's do that over to the side, because in the next step we'll write that down. So b over 2a squared, that means multiply the numerator times itself. B times b would be b squared. Multiply the denominator times itself. 2a times 2a would be 4a squared. Okay? So that's what b over 2a squared is. Now the left side is guaranteed to factor. Why is it guaranteed to factor? Because of the method that we go through. It guarantees that we get a perfect square on the left side. So that perfect square would be x, look at the sign in front of the middle term, plus, plus, and then whatever we squared we put here and here. So b over 2a and b over 2a. We put there and there. Alright, on the right side, here I'm going to go ahead and write it out squared. So, and I'm also, since it's a positive term, you see it's plus, I'm going to write it in front of this other term. So I would have b squared over 4a squared minus c over a. Okay. So on the left side I have x plus b over 2a squared equals, now I do have to get a fraction right here. What would that be? Well, to get a common denominator, my common denominator is going to be 4, and then you have to take the largest. And this may be, even if you've understood it to this point, you may get a little confused here. But your common denominator is 4a squared. And so what you would do, since this has a 4a squared, you just write b squared up top, minus, because there's a minus. Now here we don't have 4a squared. So you have to take 4a squared and divide it by a. That would just give you 4a. And say that times c. So that would be 4ac. Okay? I know it's a little confusing, but really we're just following the same steps that we would if we were completing the square, and then we had to do a little algebra to make these two fractions into one fraction. Now what did we do next? We took the square root. If we were doing completing the square, we take the square root of both sides. Okay? And when you take the square root of something squared, that cancels out. So I'd have x plus b over 2a equals. Now when you take the square root of a fraction, that's the same thing as the square root of the numerator over the square root of the denominator. And what do we have to remember to put in front of the one side? We got to put a, when you take square root of both sides, you have to put what in front of one side? Plus or minus, right? And so I can break this up, the square root of the numerator over the square root of the denominator. Alright, I'm almost done. So I have x equals, now let's take b over 2a and move it to the right side in front of that plus or minus. So that's negative b over 2a plus or minus the square root of b squared minus 4ac over, well, what's the square root of 4a squared? The square root of 4 is 2, and the square root of a squared is a. Now they have the same denominator. Anytime you have fractions with the same denominator, you can write the numerators over that common denominator. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I just went through something, again, most of my calculus students probably couldn't do that. But using a little tricky algebra and completing the square, I was able to go through and show you how the quadratic formula came about.